Hello all, this is Anita. Welcome to the machine learning video lecture series. In this lecture, we will understand one of the bagging technique, that is random forest, in detail. So let's get started. So here first we will understand what is random forest. So as I have told you, random forest is one of the bagging technique. Random forest is a supervised machine learning algorithm. It can be used for both classification and regression problem in the machine learning. It is based on the concept of ensemble learning, which is the process of combining the multiple classifiers to solve the complex problem and to improve the performance of the model. A random forest is like a group of decision-making team in the machine learning. It combines the opinion of the many trees to make the better predictions, creating the more robust and accurate overall model. Now, let us understand the random forest concept with the real life analogy. Suppose a student wants to choose a course after his 12th. So he is confused about the choices of the course based on his skill set. So he decided to consult to the various people like his cousin, teacher, parent, or the degree student or the working people. He asked them various questions like why should he choose that course. The second one is what are the job opportunity with that course, then the course fees, and finally, after consulting the various people about the course, he decide to take the course generated by the suggested by the most people. Now we will understand the bagging, that is random forest technique, in detail with the help of the diagram. So here you can see, suppose I am having some data set D containing m number of columns or m features and the D records. So here I am considering the binary classification problem, and here based on this data set I am creating the model, and this model here I am using the decision tree. So from this data set we pick up some sample of rows and some features and giving to the decision tree. So here I am using the random sampling and feature sampling technique and giving these features to the decision tree one, and based on that this model is trained. Similarly, I am doing for the D2. So again, for D2, the row sampling happen with replacement and giving it to the decision tree 2. Similarly, for every decision tree, these things happen. So whenever I get my test data and give it to the decision tree, it gives me the output as a 1. And the second one is gives me the output as a 0. The third one gives me the output as a 1. So likewise, so for aggregating, I am using here the majority vote. So finally, the output is 1. So here you can see the base learner is the decision tree. Now you should understand what happened when we use the multiple decision tree. So here we have used the multiple decision tree. So as you know that when we have learned the decision tree concept. So in decision tree, it has the two properties. Like suppose I am creating the decision tree to its complete depth, and when I do that, it basically has the two problem like low bias and the high variance problem. So this low bias is yeah, it will properly train on the training data set, and the training error will be very less. And with the high variance problem, uh, whenever we get the new test data, so those decision tree, they are prone to give the large amount of error. So in random forest, we are using the multiple decision tree. Here you can see multiple decision tree, and each tree will be having the high variance problem. But when you combine these all the decision tree or that high variance problem with respect to that majority vote. So what happened here, that high variance problem is converted into the low variance problem. So we will see that with the help of example. So here you can see, suppose in my data set total 1000 records are there. and I am here for choosing the record from this data set. I am using the row sampling and feature sampling technique for each and every decision tree. Now I am just changing the 200 record here, and these 200 record are splitted into the all the decision tree. So this data change will not make impact on the decision tree 1, 2, 3, and so on with respect to the output. So that is why our high variance problem is converted into the low variance problem. Now, similarly, here you can see that here our input data is there. So in random forest model, the subset of data point and the subset of features is selected from this input data, and we are constructing the decision tree 1, 2, 3 likewise. So here simply we put n random record and m feature are taken from this data set having the k number of records. And in step 2 what we are doing, the individual decision trees are constructed for each sample, and each decision tree will generate an output. So final output is considered based on the majority voting or the averaging for the classification and the regression problem. Now we will understand the random forest with the help of the example. So here you can see, consider I am having some fruit basket as the data set, and as shown in this diagram, now n number of samples are taken from these fruit baskets, and individual decision tree is constructed for each sample. So each decision tree will generate the output as shown in the diagram. You can see first decision tree is generating apple, second one is giving the apple as a output, the third one is giving the banana as output. So the final output is considered based on the majority of voting. So here you can see the majority decision tree gives the output as a apple, so when compared with the banana, so the final output is taken as an apple. So this is how the random forest work. Now, let us understand what are the advantages of the random forest. So, it reduces the overfitting problem in the decision tree and helps to improve the accuracy. Now, it is flexible to both classification and the regression problem. It works well with the categorical and the continuous values. It automates the missing values present in the data. Now let us understand what are the disadvantages of the random forest. So it increases the increased accuracy required more trees. So more trees slow down the model, and it can't describe the relationship within the tree. Now, let us understand the applications of the random forest. So, one of the most popular application is random forest used in the banking sector. So, in banking, banking analysis required lot of efforts as it contain the high risk of the profit and the loss. So, the in customer analysis, then for finding the fraud detection, so that random forest will be used. Now, the second one is the healthcare sector. So, in pharmaceutical industries, random forest can be used to identify the potentials of the certain medicines or the composition of the chemicals requirements for the medicine. It can also be used in the hospitals to identify the diseases suffered by the patients, risk of the cancer in the patient, and many other diseases where early analysis and the research play a very crucial role. So these are the applications of the random forest. Thank you.